section. This is a lot easier than the last section. So let's just kind of crash into it. So this is parametric equations. All right, so plane curves and parametric equations. So f and g are functions on an interval, and then for a set of points, we're going to use t, which is what we're going to plug into our function. We get a plane curve. So these are called parametric equations, but the resulting thing is called the plane curve. And so we're going to use t for some interval in this. So here we're going to sketch a curve. So how are we going to do this? So the first thing we're going to do is, so we're going to just use these equations. That's all we're going to do, is we're going to use these equations to produce our values. And so here we're just going to start. Let's start at -2, -1, 0, 1, 2, 3, 4. Should be good enough. So if t is -2, plug it in here. -2 squared minus 3 times the -2 will give us 4 plus 6, so it'll be 10. And then if we plug it in here, we'll have -2 minus 1 will be -3. Here we'll have a -1. So -1 squared minus 3 times minus 3 times -1, so this will be 1 plus 3, so this will be 4. This gives us -2. Notice here this is just real simple. This is just 0, 1, 2, 3. Oops, hold on. This will be -1, 0, 1, 2, 3. It just goes up by 1 each time. Here, if we actually crunch through this, is 0, -2, -2, 0, and 4. And so let's crunch through this. So when t is -2, here we're at 10 and 3. So here we're way out here. So because I have 1, 2, 3, 4, 5, 6, 7, 8, so it'll be 9, 10, and then -3, so we're here. And then when t is -1, we're at 4. So 1, 2, 3, 4, and -2. When t is 0, we're at 0 and -1. When t is 1, we're at -2 and 0. And then we'll be, when t is 2, it's at -2 and 1. And then we'll be at 0 and 2. And then we'll be at 4 and 3. Okay, so here we are. And notice we kind of just sketched this in vaguely. It looks like this. However, we can also use Desmos to graph this. And so in here in Desmos, we'll just type in, we'll use parentheses. And so our parentheses will write t minus, and so this is how you type it in. Here's our x, here's this, and then here you can just type in from -10 to 10, and here's our graph, okay? And so here we can see that we're going to sketch this, and as t moves forward, in fact here if we, as t moves forward, we can just kind of just notice that t slowly sketches this out, alright? Now, one of the things we can do, for some of these, but not all of them, is we can, often can we to a single rectangular coordinate x and y. One way to do this is to solve the equation for t and substitute into the other. And so in this case, we can say that t is equal to y plus 1. And then we can plug that into here. So we'll have x equal to y plus 1 squared minus 3 of y plus 1. And then once we solve, now if we simplify this, we end up, this becomes, if you just do the math, it's y squared minus y minus 2. Okay? And so here we can have x as written as this, and we can also graph that. Alright, so let's just do 2 more real quick. So here we're going to have x is sine of t and cosine of t. Alright, so let's just start at t equal to And so notice here what makes the best sense for us to do is 0. And let's just do like pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and then 3 pi over 2. And the reason we do that is we easily know what these are, right? So cosine of 0 is 1, sine of 0 is 0. Cosine of pi over 2 is 1 over the square root of 2, and 1 over the square root of 2. Here we'll have 0 and 1. Here we'll have x will be minus 1 over the square root of 2, and this will be 1 over square root of 2. Here this will be minus 1 and 0. Here we'll have minus 1 over the square root of 2, minus 1 over the square root of 2, and then 0 and minus 1. And so here we're just going to go ahead and just put that here. So it'll be here, 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 here. And so here we just run t for this amount. In fact, if we run t from, notice that once we get here, this will just kind of go into a circle. And so this is just going to spin around and around and around as t goes forward. Okay? All right. And so let's go ahead and try to eliminate. So notice here, we could write this as x squared plus y squared is equal to 1, because this is a circle of degree 1. And so here we've eliminated the parameter. I'll show you how to do this another way in a second. So we did it one way here. Here you can just kind of discern what it is in order to satisfy it. Since we have a circle here, you can just write down an equation, and here we'll show you a third way of doing this. But first, let's just crunch through some numbers. So let's crunch through some numbers, and so here we're going to just have, so here we have sine and cosine again, so let's just do the same numbers. So let's do pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and just because it makes easy numbers for us to crunch through. Alright, so sine, this will be 0, and this will be 2 minus 1, so this is 1. Okay, and then here we'll have square root of 2, and then 2 minus the square root of 2 squared, so this will be 2 minus a half, so this will be 3 halves, right? 2 minus a. And so here, this will be 1, and then here this will become 0, so this will be 2. And then here we'll have square root of 2. And this will be 3 halves again, because notice since we square it, the negative doesn't matter. This will become 0. Hold on. And so, sorry, one of my dogs decided to eat each other. So here we'll have 0. And then cosine squared, so this is still 1. And then we'll have minus square root of 2, 3 halves. And then here I'll have minus 1 and 2. And so if we look at that, that'll be here, 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 and here. And so this just kind of looks like this little parabola. So let's graph that real quick in our Desmos. Alright, so let's go ahead and grab Desmos. So here we're going to just type in, so here we'll just go ahead and get this thing. We'll go ahead and type in sine of t. We'll type in 2 minus cosine squared t. And we have exactly what we designed. Okay? All right, and so notice what this is going to do here is it's going to start here. It's going to go up, hit this, come back down, come back, go up, hit this, come back down, go back. And so this just goes over and over and over again. So, so that's what we have. All right, so now, oops, stay on the page. We'll leave that in case we want it for later. So what do we have here? So let's go ahead and do this. Can I write one in terms of the other? Sure, right? So here, I can write this as y equals 2 minus here we can have 2 minus 1 minus sine squared t. But do I know what sine squared t is? Yeah, it's x. So here I'll have y equals 2 minus the 1 minus x squared, which is just equal to y equals 1 plus x squared. But notice that this has to be between 0, since sine of t has to be between 0 and 1, x can only be between 0, or between negative 1, sorry. X can only be between negative 1 and 1, so this is what we get here. Okay. Alright, so let's look at the very last thing. So we can use graphing calculators to graph a whole bunch of things. So let me show you how to do a couple of them. Alright. So let's go ahead and use Desmos for these, alright? And so here we have Desmos. So let's type in the first one. So let's just do our random one first. So we'll have 2t and then cosine of 2t. Hold on. Alright, and I have this. Oh, this is supposed to be up front too. Cosine of t. And so we get this really weird, we get this pattern here. So here, you can use a graphing calculator to do this. One thing is a cycloid. A cycloid is, hold on one second. So the stars are just a way for me to make cuts. Alright, so here we can have this. Notice these can get very fancy. So here we can have like 3. You can put in a 6 here, and that just extends it. Here I can put in different things, and you can get really fancy things. So these are fun. One of the things is a cycloid. Cycloid's if I have a wheel, let me just draw this real quick. So if I have a wheel, and as I monitor a point on it, it's going to look something like this as it bounces around. So if you just mark a point on the wheel and do that, it's called a cycloid. And we can use parametric equations to simulate that. So so in this case, let's just make our A 2. And so here, it'll be 2 times t. So we'll go ahead and use t, because that's what we've been using. Oops. I can minus sine of t. I'll just go ahead and leave this as clean as possible, and then we'll have 2. And then here, we'll have 2. 1 minus cosine of t. There we go. And then we'll just look at this, and we'll just zoom way out. And so here, this is a cycloid. Let's just go from minus 100 to a positive 100. And so here, if we look at a point in the wheel, it's going to go boop, boop, boop until the wheel spins around. We use this in physics, and so this is one of the use of parametric equations. And so the very last thing we kind of want to go over is parametric equation for polar. So convert, so r equals to theta, and so we're going to convert this into a parametric equation and then graph it. And so here, so if we're going to do this, So here if we have r equals f theta, we can write that as a parametric equation as f of t is sine of t. So here, so x would be, so theta, so this is just theta, so our function, our f of theta is equal to theta, or f of t is equal to t. And so here we have t sine of t, or no, t cosine of t, sorry, cosine of t, y equal to t sine of t. And then let's graph it real quick, and we'll be done with this section. So this section is much easier than the other two. So you have one hard section and one easy section this week, if I still use the same formatting. Alright, so here, we'll just type this in as t cosine t, and then, yeah, that looks mighty interesting, doesn't it? And then we'll have t sine of t. Alright, so here we get spirals. And so here it's, and so here we get this very interesting thing. So it's not quite a spiral, but it's certainly an interesting graph to say the least. So we have t cosine of t, t sine of t, and so notice that sine, this goes positive and negative, and so here we have positive, negative, and it goes out and out and out. Let's just do from 10 to minus 10. So here you can kind of see where it starts. So here we start. Let's do from 0 to 10. Let's do from 0 to 10. So here, from 0 to 10, it just starts spiraling out, right? And then if we do it to 100, it spirals onward to infinity. And notice if we go negatively, we'll have negative r, and so we'll be pulling inwards, and so. And that's just the graph of those. Okay? And so what you set here matters, depending on what it looks like, because notice how this looks massively different. Let's just do it at 100. So this looks massively different than if I said t has to start at 0. And there's things that make sense that t start at 0. Like we're doing a cycloid, I'm going to start my time when I start moving my wheel, so that's 0. Okay, and that's the end of these notes. Yeah, let's go ahead and get rid of this, and then we'll stop the video.